Hi guys and girls, so welcome to this video. So for the last video, actually I already discussed with you based on the Newton's first law. So let's carry on with another Newton's law. It's called the Newton's second law of motion. So let's look at that. So according to the Newton's second law, I call this an N2. So what is a Newton's second law definition will looks like? Here we go. According to the Newton, as you can see from the definition, okay, again, one more time, as I always say that the scientists is always like to use some kind of technical word to confuse it, to make us confused that we do not know what they are referring and what they are talking about. So basically, what is the main idea of that is not that difficult to understand. So let me share with you what is going on with it. So according to the Newton's second law, say that the force that apply on a certain object basically is proportional to the rate of change of momentum. So always remember this, and anytime and every time when you see the word rate, that means that something need to be divided by time. Something need to be divided by time. All right, that is called a rate. And according to the definition, say that it's a rate of change of momentum. So we have to put the change of momentum on top. So that is the definition based on the Newton's second law. Force actually is proportional to the rate of change of momentum. Maybe when you look into that, okay, what is the main point of it? What is trying to tell us? So basically this one can be changed it becoming a formula pattern and formula form. So it turns into a force, we can write it as a symbol as a F. All right, proportion to the rate of change. Rate means divided by time. The change of momentum. What do I mean by momentum? Momentum basically is the product of the mass and velocity. The change of momentum basically is referring to the final momentum with minus with the initial, the difference of it. So what we can do from here is you take the final momentum, you minus with the initial momentum. So that is what we call as a change of momentum now. All right, so what we can do from here is, as we know before that is, one of the formula is called the acceleration. Acceleration formula is written as v minus u divided by the t. So just because of that, I can try to factorize the m becoming a v minus u divided by the t, just like that. So they will turn into F proportional to the ma. Okay, so now you can see that the entire equation actually or proportion here. So what's the next thing you have to do? We must understand that in order to convert a proportion to become an equation, this is basically a high school math. So we just have to make it become an equal. Yes, you just have to make it become equal. Then you have to maintain the entire equation that you have originally by adding one of the thing in front of that. Is what we call as a k. K normally we call it as a constant. So we have to add a constant in front of the ma in order to make entire work. So F equals to kma. Okay, what is this now? What does this k represent? So I want you to understand that force, right, actually can be written and can be measured in terms of Newton. Or the short form, we call this an N. I think a lot of you know about it. But I want you to understand that Newton actually is a name of a person. Newton is a name of a person. Newton is the one who taught us all about this. Then you might understand that 300 years ago, when Newton tell everyone that, oh, hi, everyone, please use my name as a unit. Please use my name as a unit. So if you listen to this kind of what we call instruction, what's the first thing you have to ask? How to use, right? Yeah, I'm going to use your name as a unit. Yeah, Newton. Yeah, I know. But how to use? Of course, nowadays we know how to use. But those days, you imagine that 300 years ago, Newton suddenly announced to everyone that please use my name as a unit. But how to use his name as a unit? So we have to know how to use. Am I right? How to use. So now this is what Newton told us that. Okay, Newton say that, okay, let me erase this part. I need some space here. Newton say that every 1 Newton is the force. 1 Newton, it means that teaching the public how to use his name. Newton. 1 Newton is the force applied to accelerate 1 meter per second of 1 kg object. This is what he means. It means that he said every 1 Newton actually referring to a force that you apply to push the object, to accelerate the object, to make the object faster by 1 meter per second for every 1 kg of object. That is a definition of 1 Newton. That's how he explained to us how to use his name. And just because of this definition, let me carry on from there. So, we're going to have F equals to kma. So, because the force over here is 1 Newton, 1 Newton actually is a force to accelerate 1 kg of material for 1 meter per second. So as a result, conclusion, K basically is equal with 1. So that's the reason why, in common, we will say F is equals to ma. So that is a formula from the Newton's second law. But of course, when you look into the formula, the calculation of the formula is not the most tricky part to learn this. This is not difficult to apply, I would say. You just plug in the value of the M and the A and the F and so on, you will find respecting value. The most important thing is you must understand the idea behind this. The idea behind this. So let me use this part over here. Okay, according to Newton, what is the main idea here? He said that F is equals to ma, where the K is equal with the 1. So as we know that we also can return this as a m, okay, v minus u divided by the t. Okay, so now this is a very important kind of arrangement now. So what is happening now is like this. Okay, now I want you to imagine that. If you imagine that in order for you to create a maximum force, that means that in order for you to create the highest force that you can, what you need to do, according to the arrangement of this formula, F and T, when any kind of alphabet is located at the bottom of the entire equation, is considered as inversely proportional. That means that when you want to increase the F, you have to reduce the T. What do you mean by reducing the T? That means that in order for you to create a maximum force, you have to use the shortest time as you can. The shortest time to create that force. So that's the reason why I always tell my students, you imagine that when someone gonna punch you, for example, okay, of course, I'm not supporting violence, it's just an example. So when someone gonna punch you, if the one hold like this and gonna punch, that is not a very good act, because when you hold like this and punch, you will take a very long time to reach the target. So when the time is increasing, the force that you apply will reduce. That means that it's impossible for you to create a maximum force. So in order for you to create a maximum force, you have to use the shortest time as you can. Shortest time, direct, straightforward. When you do like that and punch, and you know that this kind of act is always happen in the most of the Japanese anime. When they punch, just keep screaming, ha! Okay, they will scream for whole episode until the feast also haven't reached the opponent face. All right, so that's not good. Okay, that's not good. We are learning physics here, so have to use the shorter times that you can. Okay, not only that, as you can see, the M is located on top. That means you need to use a high mass in order to create a maximum force, and that is logical. When someone slap you like that, you feel painful. When someone holding a brick and hit on you, you feel much more painful. Why? A lot of people misunderstand that. They say, oh, because the brick is hard. The brick is so strong, so that's why I feel painful. No, it's not because of the brick. It's because of the mass. So basically, when you hit you like that, that's the mass of hitting you. When you're holding a brick, the entire mass of hitting you will increase. So that's why you feel more force, more painful. Of course, on the other hand, reduce this, you will reduce that. And now come to one of the most important part, is this one over here. The whole thing, the whole bracket. In order for you to get a maximum force, you have to increase this whole thing here. Okay, how to increase this whole thing here? Now you look at this part. V minus U, I have to make sure that it's a maximum value. I need to make sure that it must be a maximum value, the highest. This is a simple mathematical thing. You see, in order to become a maximum, this is a minus. It's a minus. That means that you have to make sure that the V must be maximum and the U must be a minimum, right? When you're taking a maximum minus the minimum, obviously you get a maximum answer. Okay? So now you can see what is the minimum value for the U? What's the lowest we can find? I want you to understand that lowest in physics is not a negative. Negative in physics is always representing an opposite direction. So U, the minimum we can find, is called a 0. Because nothing slower than you are not moving. Okay, in other way, you can see from here. In order for it to create a maximum force, this must be max. How to create a max? U must be min. How to create minimum? 0. In other way, in order for you to punch, you have to make sure that at the beginning you must stop, then move. Stop, move. That is one of the way to create the strongest force that you can. That's why you can see that one of the famous martial artists in the 1970s, which is called Bruce Lee. Okay, Bruce Lee, one of the famous act that we have is called the 1-inch punch. He just hold like that and punch. So basically, he using a very short period of time and having an initial velocity of 0, then hit on it with the maximum final velocity. And that will create a maximum force. Same thing when you look at some of the professional boxers, they will hold the hand like that. So when they punch, stop, punch, stop, punch, stop, punch. They will not stop. That is not good. That is not a professional. Understand? And one more time, I just want to clarify here, I'm not supporting violence. I just use some of the example that we can apply in the real life to learn in physics only. Please do not go and hit your friend and punch your friend. Please, it's just an example. All right? And that's all for this episode. Thank you very much for watching this video. I will see you in the next video. Bye-bye.